Swayam Prabha. Digital India. Educated India.
Now we are going to discuss how to combine neural networks with fuzzy logic just to develop a neuro-fuzzy system. Now, this particular neuro-fuzzy system has got a number of practical applications. Now, here actually what we are going to do, we are going to concentrate on two neuro-fuzzy systems. One is based on the Mamdani approach and another is based on the Takagi and Sugeno's approach. Now, both Mamdani approach and Takagi and Sugeno's approach we have discussed in details and we have solved some numerical examples. Now, let us see how to develop the neuro-fuzzy system for this Mamdani approach and Takagi and Sugeno's approach. Now, let us concentrate on this combined neural network and fuzzy logic. Now, as I told that this neuro-fuzzy system, so actually in short this is known as NFS. Here the purpose is to improve the performance of this fuzzy reasoning tool, and what we do is the fuzzy reasoning tool or fuzzy logic controller we represent using the structure of a neural network, and this network is trained using either a BP algorithm or a genetic algorithm or any other nature inspired optimization tool. But basically the main purpose of developing the neuro-fuzzy system is to design and develop the fuzzy reasoning tool or fuzzy logic controller. Now, if you see this literature, now neural network and fuzzy logic have been combined in fact in two different ways. One is called the neuro-fuzzy system and another is called the fuzzy neural network. Now, if you see the fuzzy neural network, now here actually what we do is we try to represent the neurons of a neural network using the concept of the fuzzy set theory. And in your fuzzy neural network actually there are three different ways through which we can develop. We can consider the real inputs and fuzzy weights. This is one way of developing the fuzzy neural network. Then comes we can consider the fuzzy inputs, but real weights, and we can also consider fuzzy inputs and fuzzy weights. Now, let me repeat. So, this fuzzy neural network can be implemented in three different ways as I told, but unfortunately, so this fuzzy neural network could not reach much popularity. On the other hand, the neuro-fuzzy system, that is your NFS, could reach a huge popularity just to solve the different types of the real world problems, and that is why actually in this course. So, I am just going to consider on the neuro-fuzzy system. Now, this neuro-fuzzy system, as I told that this is known as NFS, and here I am just going to discuss the neuro-fuzzy system based on the Mamdani approach. Now, let us see the Mamdani approach of fuzzy reasoning tool or fuzzy logic controller, how to represent using the structure of a neural network, and so that we can develop the neuro-fuzzy system. But let me repeat once again, the main purpose of developing this neuro-fuzzy system is to design or evolve rather the fuzzy reasoning tool, very efficient fuzzy reasoning tool which can perform the input output relationship. Now, if you remember, in Mamdani approach we have got a few steps. For example, say we try to identify the inputs and outputs. Now, once those inputs and outputs are identified, then we actually went for some sort of fuzzification, and once you have got the fuzzified values for the input parameters, then we in fact implemented the inference, the fuzzy inference, and through this particular fuzzy inference we got some output, and those outputs are nothing but the fuzzified outputs. And once you got that fuzzified output, we went for the defuzzification, so that we can find out the crisp value of these particular the output. Now, here, so this shows actually the schematic view of one Neuro-Fuzzy system, very simple Neuro-Fuzzy system having the two inputs and one output, and this particular network it consists of 5 layers. So, we have got this input layer. So, this is the input layer, the first layer is the input layer, the second layer is actually the fuzzification layer, third layer is known as the AND operation layer, then comes the fourth layer is nothing but fuzzy inference, and the fifth layer is nothing but is your defuzzification. Now, look wise this is similar to a particular the network, but truly speaking this is nothing but the Mamdani approach of fuzzy reasoning tool. Now, what is the reason that why do you consider the structure of the neural network to represent a particular the fuzzy reasoning tool? Now, the answer is very simple. We use the structure of this particular network to implement or to actually represent the fuzzy reasoning tool or fuzzy logic controller based on Mamdani approach, so that we can modify this particular network in order to train the Mamdani approach of fuzzy reasoning tool using the principle of either the back propagation algorithm, or we can use some sort of nature inspired optimization tool like genetic algorithms and others. So, that is the main purpose why did we take the help of this type of the structure of the network. Now, here if you see we have got two inputs like your I1 and I2. So, on the first layer, so here you can see I have written I1, that is the input of the first neuron lying on the input layer, and this is I2, that is the input of the second neuron lying on the first layer, and here I have got actually 101, that is the output of the first neuron lying on the first layer, and then 102, that is the output of the second neuron lying on the first layer. So, the first layer is nothing but the input layer. Now, here, so this is actually the second layer is the fuzzification layer. Now, the purpose of fuzzification is to find out the normalized value corresponding to these particular the inputs. Now, how to implement? So, that I am going to discuss in details. Now, once you have got the fuzzified output, and so here you will be getting the outputs of layer 2 is nothing but the values of the memberships. Now, these membership values for the two inputs I1 and I2, I will have to use here as input of the layer 3, and on layer 3 actually we will have to carry out the AND operation. And if you remember in AND operation, so what we do is, so we try to compare the two mu values and we try to find out the minimum. Now, this minimum of these two mu values will be considered as output of layer 3 or the third layer, and layer 4 is nothing but the fuzzy inference layer. And as we have discussed, the purpose of fuzzy inference is to select the set of fired rules corresponding to one set of input parameters. Now, in the rule base we have got a large number of rules. So, out of these large number of rules only a few will be fired depending on the set of inputs. Now, fuzzy inference is going to decide which ones the rules are going to be fired out of the maximum number of rules present in that particular the rule base. Now, once we pass through this particular the fourth layer or the layer 4. So, I will be getting actually the output here, and these outputs are denoted by actually 401, that is nothing but the output of the first neuron lying on the fourth layer and so on, and here those things will enter as input to the fifth layer or the defuzzification layer, and as output of this defuzzification layer. So, I will be getting some crisp output. Now, this is the way actually it works in short, but I will be discussing in much more details, and after that we will be solving one numerical examples also. Now, let us see. Now, let us see this the principle in much more details. Now, here for simplicity we have assumed that both the inputs and the output are having actually the triangular membership function distribution. For example, say, so these are nothing but the membership function distribution for your I 1. So, the first input are expressed using 3 linguistic terms like your low, medium and high. Similarly, 4 other linguistic terms are used to represent I 2. For example, we have got very near, near, far and very far, and the output is actually represented using 3 other linguistic terms. So, S is nothing but slow, F is nothing but fast and Vf is nothing but is your very fast. So, for these 2 inputs and 1 output, so we used actually the triangular membership function distribution. Now, let us see how to proceed with this the designing of this Neuro-Fuzzy system. Now, as there are 3 inputs for these particular as there are 3 linguistic terms for this I 1 and there are 4 linguistic terms for this your I 2. So, we have got 3 multiplied by 4 rules. So, we have got actually 12 rules. The rules are as follows: if I 1 is low and I 2 is very near, then the output is your S. So, S is nothing but the slow. So, this is the way actually we designed these particular the 12 rules. So, these 12 rules are designed something like this. Now, I am just going to represent actually a particular neuron lying on each of the layers. Now, for the purpose of analysis, so here we are going to consider the jth neuron lying on the first layer, then comes your the jth neuron lying on the first layer, then the kth neuron lying on the second layer, lth neuron lying on the third layer, and mth neuron lying on the fourth layer, and nth neuron lying on the fifth layer. Now, the connecting weight between the layer 1 and the layer 2 is denoted by V. The connecting weight between your layer 4 and the layer 5 is denoted by your the W matrix. Now, the nomenclature let me explain once again. So, 1 I j is nothing but the input of the jth neuron lying on the first layer, then 1 O j, that is the output of the jth neuron lying on the first layer, then your 2 I k, that is the input of the kth neuron lying on the second layer, then 2 O k, that is the output of the kth neuron lying on the second layer, then 3 I k, the input of the first neuron the lth neuron lying on the third layer, the 3 OL, that is the output of the lth neuron lying on the third layer, then 4 IM, that is the input of the mth neuron lying on the fourth layer, then 4 OM, that is the output of the mth neuron lying on the fourth layer, then 5 IN, that is the input of the nth neuron lying on the fifth layer, then 5 ON, that is the output of the nth neuron lying on the fifth layer. And as I mentioned, the first layer we use some sort of linear transfer function, that is output is nothing but the input. In layer 2, we carry out fuzzification, that means we try to find out the membership function value denoted by mu, which we have already discussed. Layer 3, actually here it indicates all 12 rules and we carry out. So, this particular the AND operation, that means we compare two mu values corresponding to the two inputs and we try to find out the minimum. Then layer 4 is nothing but the fuzzy inference and layer 5 is the defuzzification, so that we can find out like what should be the crisp output corresponding to that fuzzified output. Now, let us see how does it work. Now, if you once again look into your, so this network, so here you can see that we have got some connecting weights like your V11, then comes V12, then comes V13. We have got the connecting weights like your V24, then V25, V26 and V27. Now, these are all connecting weights between layer 1 and layer 2 and these particular connecting weights lie in the range of 0 to 1. Now, here actually what we do is, so this connecting weight expressed in the normalized scale may have some other value in the real scale and that particular value in the real scale is going to represent what should be the spread of that particular the triangular membership function distribution. That means, here if it is a right angle triangle, so its base width will be represented by the connecting weight. If it is isosceles triangle, so its half base width will be represented by, so these particular the connecting weights. Now, truly speaking, V11 could be different from V12, could be different from V13. Now, what we do is, we try to find out the average of these particular 3 and then we assign that V11 is nothing but V average, V12 is nothing but V average and V13 is nothing but is your V average. Now, this is done actually just to ensure that we have got the symmetrical triangular membership function distribution. Now, if we consider asymmetrical membership function distribution, so you need not consider the average and you need not assign the average value to each of these particular the connecting weights. The same thing actually is done for, so these connecting weights also, which are going to represent the base width or the half base width of the triangular membership function distribution used to represent your the I2. Now, let us see how does it work. Now, if you see the way it has been implemented is as follows. So, here as I told that we try to find out first, so this V11, V12, V13, find out the average. Now, this particular average you assign to V11, V12 and V13. That means, V11 equals to V12 equals to V13 is nothing but V1 average. The same principle we follow here also, like V2 average is nothing but V24 plus V25 plus V26 plus V27 divided by 4, and after that we assign V 24 equals to V 25 equals to V 26 equals to V 27, and that is nothing but V 2 average. And this W average we calculate in fact for the connecting weights between the fourth layer and the fifth layer, and these particular connecting weights or the W values are going to represent what should be the size of this particular the triangular membership function distribution representing the output. The same principle we follow here. So, we find out the average of W 11, W 21, W 31, and then we assign W 11 equals to W 21 equals to W 31 is equal to W average. So, all such things we do. Now, actually the membership function distribution for the inputs and the outputs are ready, and once they are ready, now actually we are in a position to pass the set of input parameters. Now, here actually all the steps, all the 5 steps. So, once again we have written in this particular fashion. So, layer 1 we consider actually the linear transfer function, and here the outputs are kept same with the corresponding inputs. Then layer 2 is nothing but the fuzzification module, and here in this fuzzification module actually what we do is we try to find out what should be the membership function value. Now, if you concentrate on the membership function distribution of the input parameters, that is I 1 and I 2. So, you will be getting actually 3 types of triangle. So, one is this type of right angle triangle you will be getting, and you will be getting this type of right angle triangle also, and you will be getting actually this type of isosceles triangle also. Now, if you are getting this type of right angle triangle, so during the optimization or during the training, so we are going to optimize. So, this particular the base width, and if you are getting this type of right angle triangle, so we are going to optimize. So, this base width, and if you have the isosceles triangle, so we are going to optimize the half base width of this particular the triangle. And the moment we pass actually a particular the input, for example, say I am here. So, very easily I can find out what should be the mu value, because the range for mu is your 0 to 1. So, using the principle of similar triangle, so very easily you can find out the mu value. This we have already discussed in much more details. Similarly, corresponding to this, if I pass one input, so I will be able to find out so this particular the mu value. Then corresponding to this actually if I pass, then I will be getting so this as the mu value or the membership function value. Now, the same thing actually we follow just to carry out that fuzzification the step. That means, corresponding to the set of inputs you will be getting some mu value, and once you have got that particular mu value, then we go for the logical AND operation. Now, let me once again go back to the schematic view of the Neuro-Fuzzy system, and you will understand here actually what we do is, so we are passing this I 1 and I 2. So, this output is nothing but the input, and these particular connecting weights are going to represent the membership function distribution, the shape and size of the membership function distribution, and the output of the second layer is nothing but is actually the membership function value or the mu value. And as I told, so this particular AND operator or the layer 3 is going to represent the AND operator. So, we have got 12 rules. So, each of the 12 rules actually we are going to represent here. For example, if I concentrate on the first neuron of third layer, so this is nothing but if the input I 1 is low and the input I2 is your very near, then the output is nothing but, so this is your slow. So, corresponding to this particular the first neuron lying on the third layer. So, this indicates if your I1 is your low and I2 is your very near, then the output O is nothing but is your S. So, output is nothing but slow. So, this is the rule which is actually represented by the first neuron lying on the third layer. Similarly, we have got 12 such neuron just to represent the 12 rules. The moment I pass one set of inputs here I1 and I2. So, there is a possibility I will be getting actually your two such non-zero mu here. So, for example, I may get this as the non-zero mu, this as the non-zero mu. Similarly, corresponding to I2, actually I may get this as the non-zero mu, this as the non-zero mu. Then, if I get the non-zero mu here and the non-zero mu here, similarly non-zero mu and non-zero mu here. So, there is a possibility that out of these 12 rules, only 4 rules are going to be fired, and corresponding to each of the fired rules. So, we are going to find out actually what should be the fuzzy fired output, okay, and that is actually the purpose of using the fuzzy inference. So, using the fuzzy inference, so we can find out the output, the fuzzy fired output of each of the fired rules, 4 fired rules, and after that we carry out defuzzification here just to find out what should be the crisp output corresponding to this set of inputs. Now, this is the way actually your, so this particular Neuro-Fuzzy system works, that is the Mamdani approach works. Now, here if you see, so till now we have discussed up to this. Now, layer 3 we perform the logical AND operation, layer 4 we carry out the task of fuzzy inference, and there will be defuzzification on layer 5. There are several methods of defuzzification. Now, here I am discussing how to use the principle of the center of sums method. This center of sums method, in fact, I have discussed in much more details while discussing the fuzzy reasoning tool, particularly the Mamdani approach. Now, the crisp output is nothing but summation your I equals to 1 to r a I f I divided by summation I equals to 1 to r a I. So, we can find out actually what should be the crisp output, and once you have got this particular the crisp output. So, this particular crisp output can be used for your the controlling purpose. Now, let us discuss little bit how to tune or how to train this particular the Neuro-Fuzzy system. Generally, we consider the batch mode of training to train this type of Neuro-Fuzzy system. We can use either back propagation algorithm, or we can use some nature inspired optimization tool like your genetic algorithm or particle swarm optimization and so on. And using these particular the tools, actually we can optimize, and once you optimize, so now you are in a position actually to train this particular network. That means, we are basically giving training to the fuzzy reasoning tool, which works based on this particular the Mamdani approach. Thank you.